Good day, everyone. Alkynes are nonpolar unsaturated hydrocarbons with physical properties similar to alkanes and alkenes. Alkynes dissolve in organic solvent, have slight solubility in polar solvents, and are insoluble in water. Compared to alkanes and alkenes, alkynes have slightly higher boiling points. Alkynes are organic molecules with carbon-carbon triple bonds. They are unsaturated hydrocarbons with the empirical formula of CnH2n-2. The simplest alkyne is ethine, which has the common name acetylene. Therefore, knowledge of the various alkynes reactions helps in prevention of corrosion, which may occur alkynes are in contact with metal. According to corrosion media, explains that alkynes is just like alkenes. Alkynes contain overlaps of the carbon orbitals, thus creating a weak region between the carbon atoms. This region is where the electron pair are situated and the bands form, wherein these regions are pi bonds. Pi bonds are weaker than sigma bonds. Therefore, the reactivity of alkynes ensures that the sigma bonds are reduced, so that the structure is strong and stable. Alkynes are reactive in that they can go through addition and reduction reactions. The acidity of alkynes might be weak, but the addition reaction that it undergoes with a metal surface initiates the corrosion process. Some types of alkynes, like acetylene or ethine, can burn in oxygen to form water and carbon monoxide, which are necessities of corrosion. Certain polymers of the alkynes can be used as corrosion inhibitors or cathodes. Now let's find the structure of ethine. The common name of ethine is acetylene. We have triple bond between the two carbon atoms. Now we have to fit two hydrogen atoms, one hydrogen atoms at each carbon. As you see, the two hydrogen atoms are at the most maximum distance away from each other. And this is the structure of ethine. Let's observe the structure again. These are the two carbon atoms that they are linked to each other by a triple bond. And the two hydrogen atoms take this position such that they are at the maximum away from each other. We know that the alkynes is unsaturated hydrocarbons having the general formula of CnH2n-2. By using the formula, we see that the first three hydrocarbons are alkynes. The first is ethine, having the molecular formula of C2H2, and this is the abbreviated or condensed formula. These two hydrocarbons are linked to each other by a triple bond. Similarly to propane, we have the molecular formula of C3H4 and the condensed formula. And to butane, the molecular formula of C4H6 and to be abbreviated or condensed formula.
Today, we will discuss about the Alkynes rules for alkyne chemistry. Rule number 1 is the Y and E suffix indicates an alkyne or cycloalkyne. Rule number 2 is the longest chain chosen for the root name must include both carbon atoms of the triple bonds. Rule number 3 is the root chain must be numbered from the anteriorest triple band carbon atom. If the triple band is in the center of the chain, the nearest subsequent root is used to determine the end where numbering starts. Rule number 4, the smaller of the two numbers designated the carbon atoms of the triple band is used as the triple band. Rule number 5 is if several multiple bands are present, each must be assigned a locator number. Double bands precede triple bands in the IUPAC name, but the chain is numbered from the end regardless of its nature. So that's the 5 IUPAC rules of naming nomenclature alkynes. But before we proceed to naming the nomenclature alkynes, we should know first the carbon straight chain and numerical prefixes used in naming molecular compounds. The first carbon straight chain are 1 is at, 2 is at, 3 is root, 4 is what, 5 is at, 6 is hex, 7 is hept, 8 is oct, 9 is not, and 10 is deck. And the first 10 numerical prefixes are 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Alright, the 5 IUPAC rules of naming nomenclature alkynes. So we got this example of molecular structure. So the first thing we should do is we should find first the longest chain. Then we should number the longest chain starting at the end closest to the triple band. So where the triple band is located? So here it is. So we should put some dots or carbon so we identify them. So we got 3 carbons. So 1, 2, and 3. After numbering, we should label or name them that corresponds carbon in alphabetical order. So we should start with number 1. 1. Should put some 1. And then we get 3 carbons. So according to the carbon straight chain, 3 is group. And we're naming alkynes, right? So we should put some Y and E. And then next is this Cl. Cl is chloro, right? And then the fluoro is connected to 3, the third carbon. 3 chloro. As what I have said, it must be alphabetical order. So C comes first to P. So 3 chloro, 1 pi. So this is the final name of that molecular structure. The next example, we get this molecular structure. As we have to remember, the first thing we should know is find the first longest carbon. So we will do the same. We will color it with highlighter. Okay. And the triple band locates here. So we should put some dots here. Let's see the carbons. Okay, 1, 2, 3, and 4, and 5. We get 5 carbons. Name them that corresponds carbons in alphabetical order. So we got 2, nearest to the triple band. This is the triple band. Okay, we got 2. Then next is we got 5 carbons. This is it. We got 5 carbons. And 5 is pent according to carbon straight chain. Pent. And we are naming alkynes, right? Nomenclature alkynes. So we should put Y and E. So the name of this molecular structure is 2-pentane. Okay, we got it.
Quantum mechanics help us in an extraordinary arrangement to concentrate on the design of various particles found in nature. The idea of synthetic holding and blend with quantum mechanics has uncovered various data about different natural and inorganic mixture that are fundamental forever. This article manages the construction of an extraordinary class of natural mixtures known as alkynes. Acetylene is the least complex individual from the alkyne family. Alkynes are unsaturated hydrocarbons in which a carbon-carbon triple security exists between the two carbon iotas. Alkynes are natural or carbon-based mixtures that contain a triple connection between two carbon molecules, in spite of the fact that alkynes are remarkable in nature and one of them is significant in industry, and some normally happening compounds do contain triple reinforced carbon. What are the sources of alkynes? Natural gas and petroleum are sources for alkynes. Modest quantities of alkynes are found in unrefined petroleum and flammable gas. Be that as it may, alkynes found in nature in plants and in certain creatures have physiological capacities. Alkynes additionally can be arranged artificially. Alkynes, a model is acetylene, C2H2, is exceptionally receptive since it has a functioning H iota in its formula. The dynamic H molecule implies that the C particles of acetylene are sp hybridized and they have half S character, and in this matter, they are profoundly electronegative and makes the contiguous H iota exceptionally acidic in nature, and hence alkynes are extremely responsive. What are the uses of alkynes? The most widely recognized type of alkynes, ethene, is utilized in planning numerous different mixtures. The most widely recognized utilization of ethene is for making natural mixture like ethanol, ethanoic corrosive, acrylic corrosive, and so forth. It is likewise utilized for making polymers and its starting materials. For example, vinyl chloride is utilized as the beginning material for PVC, and chloroprene is utilized for manufactured elastic neoprene. Ethene is utilized for planning numerous natural solvents. Alkynes are ordinarily used to misleading ready natural products. In addition, acetylene, likewise alluded as ethene, is quite possibly the most notable and generally utilized alkyne. Acetylene is extremely helpful in light of the fact that it can go through a few synthetic responses that are required in assembling items in various ventures. We should ponder plastic. We utilize plastic items for such countless things, and plastic is made utilizing a compound called polyethylene. Acetylene is a significant natural substance in the synthetic business to create polyethylene. Have you at any point knew about an acetylene light? This kind of light is utilized to cut and weld steel, and this utilizes acetylene as fuel. Lastly, one more alkyne is propane, otherwise called methacetylene, which is normally utilized as a substitute for acetylene as fuel for welding light. It is likewise being explored as consumable fuel for rocket space apparatus.
Let's move on to the type of isomer in alkynes. We have two types of isomers. First is the chain isomers, compound having molecular formula but different arrangement of carbon atoms in straight or branch chain. The second is position isomer, compounds having similar molecular formula but different position of functional group on the carbon atom. Now let's take an example. We have butane. This is but1-ine, since the triple bond is present at the position 1. So in this case, we have 4 carbon atoms and 6 hydrogen atoms. So this is the structure of but1-ine. If we write another structure, we put triple bond in the second position, so we get but2-ine. So in both the cases, you observe that the molecular formula is remain the same, but there is difference in the structure of position of but1-ine and but2-ine. So it means they are isomers. Now, what type of isomers are these two? Since there is difference in position of functional group, so these isomers are known as position isomers. Let's take another example. We have band 1-ine, in this the triple band is present at the position 1, and we get C5H8. Let's try another. We keep the triple band intact at the first position, and we move the metal group. We bring it to the third position. So in this case, we get C5H8. We have the same formula, but different structure. That is different structural formula. So what type of isomers are they? We see the functional group remains at the same position, but methyl group has moved from the straight chain to the branch form. So the type of isomer is chain isomers. That's all.